Somewhere in the Texas desert, a single building is quietly burning through more electricity than the entire city of Pittsburgh. No offices, no employees walking the halls, just racks of glowing metal, screaming fans, and enough heat pouring off them to warm a small town. All of this so that a chatbot somewhere can answer your question about lasagna recipes in half a second. And here's the part that should really stop you. Building that one facility costs more than the GDP of some small nations. Running it costs millions of dollars a day, and yet investors are lining up begging to write the check. So today we're asking the question nobody seems to be asking out loud. Is owning an AI data center one of the smartest investments of the decade or the most expensive bet in human history? Let's break down the actual economics, the real numbers, the real risks. Stick around, because by the end of this video, you'll understand why some of the richest companies on earth are betting literally everything on buildings full of very hot computers. Let's start with the number that gets thrown around. A modern AI data center, the kind built to train and run large language models, can cost anywhere from $1 billion to over $10 billion. $10 billion for a building. To put that in perspective, that's more than it costs to build an aircraft carrier. It's more than most Hollywood studios spend on their entire annual movie slate. And unlike a movie studio, a data center doesn't produce anything you can touch, taste, or hang on your wall. So where does all that money actually go? Roughly half of it, sometimes more, goes into the GPUs, the graphics processing units that do the actual thinking. A single high-end AI chip can cost between $20,000 and $40,000, and a serious data center needs tens of thousands of them to do that. Math. And you start to see why the bill balloons so fast. Then there's the building itself. These aren't your average server rooms. AI data centers need reinforced flooring to hold the weight of the racks, redundant power system, and cooling infrastructure that would make an air conditioning engineer weep with joy. Because here's the thing nobody tells you. These chips run so hot that just keeping them cool can eat up 30 to 40% of the entire facility's energy bill. And then, the quiet giant hiding in the corner of the spreadsheet, power. Not the cost of electricity, the access to electricity. Some of these facilities need as much power as a mid-sized city, and in places like Virginia or Ireland, utility companies are now telling data center developers, sorry, the grid is full. Get in line, okay? So it costs a fortune to build, but how does anyone make that money back? The business model is actually pretty simple to explain, even if the execution is brutally complex. Companies rent out computing power. Think of it like a hotel, except instead of renting rooms to tourists, you're renting GPU time to AI companies who need to train their models or run their chatbots. The big cloud players, the ones you've heard of, sign massive multi-year contracts with AI labs. We're talking deals worth tens of billions of dollars, locked in for 5, sometimes 10 years. That's the dream scenario for a data center owner, guaranteed revenue, locked in before the concrete has even dried. But here's where it gets interesting, because AI chips improve so fast, really fast. A data center owner is in a strange race against their own equipment. The chip you buy today might be considered outdated in 2 or 3 years. The revenue you generate has to not only pay back the enormous upfront costs, it has to do it fast enough that you can afford to rip everything out and upgrade before your competitors leave you in the dust. Imagine buying a Ferrari and being told that in 3 years, it'll basically be worth scrap metal because a faster, cheaper car came out. That's the depreciation clock every data center owner is racing against. Okay, enough theory. Let's actually run the numbers, because this is the part everyone skips right now. Renting out one high-end AI chip. An NVIDIA H100, the industry workhorse, goes for somewhere between $2 and $4 per GPU per hour on the open market. That chip itself costs the owners somewhere around $30,000 to buy. So let's do simple, back of the napkin math. If you rent that single chip out around the clock, every hour, all year, that's roughly $20,000 in revenue over 12 months, just from one chip at the lower end of that pricing range. Sounds decent, right? Chip pays for itself in under 2 years, not so fast. That number is revenue, not profit. You still have to subtract electricity, cooling, networking, staffing, insurance, real estate, and the interest on whatever debt you used to build the place. Once you strip all that out, the honest break-even point on the hardware alone, assuming strong, consistent rental demand, lands closer to 3 to 4 years. And remember, this whole time, faster chips are being released that make your current fleet less competitive every single year. Now, scale that up. A serious AI data center isn't running one chip, it's running tens of thousands of them. Multiply out even a modest utilization rate, and you're talking about a facility that can generate hundreds of millions, even billions of dollars a year in revenue. That's the appeal. That's why the money keeps flowing in, despite the eye-watering upfront costs. But here's the catch that separates the winners from the companies quietly bleeding cash. It's not enough to build the capacity. You need someone actually renting it consistently for years at a price that covers your costs. Empty racks don't pay the electric bill. Let's stop talking in hypotheticals and look at an actual company living this out in real time. CoreWeave started as a crypto mining operation before pivoting hard into renting out GPU computing power for AI. In 2025, the company pulled in about $5.1 billion in revenue, a huge number, up roughly 168% from the year before, making it, by some measures, the fastest cloud company in history to hit $5 billion in annual revenue. But here's the twist that proves everything we just talked about. Despite all that revenue, CoreWeave still posted a net loss for the year, over $1 billion in the red. Why? Because it was spending furiously on new data centers, chips, and infrastructure to keep up with demand, all while carrying serious debt to finance the build-out. And yet, investors aren't panicking because of one number. CoreWeave's contracted revenue backlog sits at roughly $67 billion. Money already locked in from customers for years into the future. Huge chunk of that comes from just one company, Microsoft, which alone accounts for a majority of CoreWeave's current revenue. This is the real shape of the industry. Massive revenue, massive losses, and a bet that the long-term contracts will eventually outrun the short-term burn. It's not a hypothetical gamble, it's happening right now on public markets with real winners and real risk. Now let's talk about the stuff that doesn't make it into the shiny investor presentations. First, energy costs are not fixed. They fluctuate. And when your monthly power bill can run into the tens of millions of dollars, even a small spike in energy prices can wipe out your profit margins. Second, water. Yes, water. Cooling these facilities often requires enormous amounts of water. And in drought-prone regions, this has become a genuine political fight. Some towns have literally protested against data centers moving in, worried they'll drain the local water supply. Third, the talent problem. Running one of these facilities isn't like running a warehouse. You need engineers who understand chip architecture, cooling systems, and networking at an extremely advanced level, and there simply aren't enough of them to go around. That drives salaries up and drives your operating costs up right along with them. And fourth, maybe the scariest one, demand risk. Right now, the appetite for AI computing power seems bottomless. But what happens if that demand slows down? What happens if a company builds a $10 billion facility and 2 years later, the AI boom cools off, or a competitor releases a chip that does the same job with half the hardware? Suddenly you're sitting on a building full of expensive, aging metal with nobody renting it. This isn't a hypothetical, by the way. It's happened before. Remember the dot-com bubble? Companies built enormous amounts of fiber optic cable infrastructure in the late 90s, certain the internet boom would need it all. Demand did eventually catch up, but it took years, and a lot of companies went bankrupt waiting. So with all these risks, why are the biggest companies in the world still pouring unbelievable sums of money into this? Because if you're right, if AI really does become as essential to the economy as electricity or the internet, then owning the infrastructure underneath it all is like owning the oil fields at the dawn of the automobile age. You're not betting on one company winning the AI race. You're betting on all of them needing your product to compete. It's the classic gold rush logic. You don't need to strike gold yourself, you just need to sell the shovels. And right now, GPUs and data centers are the shovels. There's also a strategic angle. Owning your own AI infrastructure means you're not dependent on a competitor's cloud platform. You're not exposed to their price hikes, and you control your own destiny and a technology that's rapidly becoming central to nearly every industry on Earth. Here's the honest answer. It depends entirely on your time horizon and your risk tolerance. If you're a massive company with billions in cash reserves and you can afford to be wrong for a few years while the market matures, this can be an extraordinary long-term investment. The companies locking in those decade-long rental contracts today are essentially guaranteeing themselves a river of revenue for years to come. But if you're a smaller player trying to jump into this space, hoping to ride the wave without the deep pockets to survive a downturn, the economics get a lot scarier. The barrier to entry is enormous. The depreciation clock never stops ticking, and the whole industry is betting that a boom that's only a few years old will keep accelerating rather than plateau. Here's the thought I want to leave you with. During the Industrial Revolution, the people who owned the factories became some of the richest people in history. During the Internet Revolution, it was the people who owned the cloud, and the AI revolution might be the people who own the buildings powering intelligence itself. That's the bet being placed right now in the desert, in old coal towns, in quiet corners of the map. most of us will never visit. Whether it pays off is one of the defining economic questions of our generation, and we're all watching it unfold in real time. If breakdowns like this are your thing, this is exactly what we do every week here on Economic Files, pulling apart the numbers behind the biggest shifts in the global economy. Hit subscribe so you don't miss the next one. See you there.